Okay, so in this video we're going to look at the reverse engineering relief options that by default is actually hidden. It's not there. We can make sure it always shows up if we go to the NURBS relief, show NURBS relief tool. If we set this to auto, it'll try and figure out if there's something there. If we set it to always, it'll always show up. So we don't have any data loaded, so that's not even considered here. I'm going to import a simple file. It's a relief file that was given to me a while ago. When you import it, there's a good chance that this dialog box will show up that says that the diagonal of the data is very large in one direction compared to the others. In this case, that's fine. 1.4 meters essentially. I don't know if that's what the file was set at, or if this is scaled up by a factor of 10 or 20 or 100 or whatever. If you want to keep it as is, just click no. If you want to go in and actually change it, it's the same thing as clicking the millimeters down here. So we're going to go and say no. And we can see that this is very thin in one dimension, but relatively large in the other two. That's the internal definition of relief. So if we click over here, now we actually see the relief data tab. If we have, like I said, in settings, if it's set to auto, this will only show up if the data matches this kind of format. So if we import it, go back to over here, it'll show up as relief data. This is somewhat specialized tool. It comes in for cases very much like this. The most likely scenario is topographical maps, or cases like this. This came from a software called Relief Maker, specifically for that. And this is already a reduced data set, so it's only 28,000 facets. If we look at the edges and turn those on with Alt and E, we can see it's relatively coarse. And the reason behind that is just I want to keep this tutorial relatively short. So the way we work with relief data is we get the option to define the specifics of that relief. And I'm going to walk through these real quick. So we got divisions in X and Y. And the assumption is always that the surface lies in the XY plane. There can be an offset in the Z or Z coordinate, that's fine. But generally it should be parallel to the XY plane. It does have a way to deal with non-parallel items, but I recommend that you always keep it as flat as possible, and if possible also keep it at the Z or Z coordinate being 0. That's generally the way it's expected to work. So we got divisions in X and Y. So what that does is it overlays a grid over that data and says, okay, we're going to split it in 10 and 10 grid locations. Don't make these too big. The application is quite capable, but if you have a lot of data and you set this number high, so say 100, it can take a very long time. And also the overall intent of this is to have relatively small data sets. So 100 grids is kind of what the application expects. The samples is within each of those grids, how many data points should it use for interpolating the NURBS surfaces that will come out of this. Make continuous, I recommend you keep this off. The intent of this is to extend the surface patch from one onto the neighboring one, and we'll see that in the preview when we do that. If you keep it turned off, we have the option of converting this into a faceted body. If it's turned on, you do not. You only get to export that. You don't get to actually work within the application. The max degree, you can set this linear, quadratic, and cubic. I strongly recommend you keep it to cubic. Some exports to quadratic don't result in good data, and linear will generally just squeeze stuff into linear sections. So again, strongly recommend keeping this on a cubic level. it's efficient, it's quick. Yeah, don't necessarily deviate from that too much. In terms of the normal, that's kind of what I mentioned as far as the XY plane. If this data is an angle, I recommend you keep the auto normal calculation on. It'll try and fit a plane through the data and figure out what the normal is. It can start deviating once the data is not well aligned, or if you have large deviations in one of the coordinates, so keep that in mind. We can also overlay onto the original data a second set of offsets, and that's done with a height map image. And anyone that's used Blender or similar knows that you can create a black and white image, or it's actually black gray image, where the color will correspond to an offset. So if we turn that on, we bring in a file, we can define what the total range of 0 to 255, which is a single byte of data, what that corresponds to, what kind of maximum height. We could also start off with a completely flat surface that has no variation in height and only use the height map as a way to define that. Otherwise, if we have this turned on, it'll superimpose one on top of the other, so it'll scale it in addition to the original. So there can be some interesting effects created that way. Generally, that won't be needed for something like this. The extent perimeter needs some explanation. So in this scenario here, the data that came in had a very square back to it, so the corners were sharp corners. Then the data was reduced using the body simplify method. And what that does is invariably actually rounds off the corners. So if you look at the edge behavior, this is rounded off. If we tell it to extend the perimeter, it'll force this into a sharp corner. And you can do a preview of this. So if we click on this, it'll show us what it does here. And it keeps the original data, but it does generate additional facets that follow the outside. So the square corner is not only a recommendation, it's actually a requirement in order for the algorithm to work properly. So keep this generally turned on. And you can see the preview of just how it's going to create that extra data with that. In terms of the output thickness, you can keep it to an absolute value. So if you want the total thickness, and the thickness is from the assumed planar section, you can set this to an absolute value of say 10 units, or you can set it to a percentage. So 10% would be 10% of this length here. Word of warning, if you set it to an absolute value and this is very small compared to this side here, there can be some of the facets on the side that will be generated can be collapsed. So keep that in mind. We're going to keep that a percentage. Going to keep that turned off. So pretty much the way it came in. We're not going to turn on the continuous option for this. We click preview, and we'll get a preview of this surface set. And this is what the application sees. So it can still see the body here. The number of samples is moderate. You know, we can probably increase this to 10 as well. We can refresh the preview, and now we can see a little bit better resolution here. If we have this at linear, it will actually not keep this continuous. It will create separate and discontinuous sections. So I can show this here like that. This may be an interesting effect. It's essentially a uniform representation, whereas if we have this cubic, you'll see that these facets actually get split up, so it's more continuous. If we like this and we want to just use as a regular STL file, for example, let's say we do some carving or something and we want it to have this more uniform, we can click this generate to mesh, and that will generate the actual body as a set of facets. If we turn on continuous, I'll show what this does in terms of the overlaps here. It generates facets that aren't unique in their edges. It's just a patch per surface. So we can't turn that into a mesh. There's far too many sections that just won't match up. It won't do anything useful. But if we export this to a step file, and I can do that here, I can go to export, and then the only option we have is step. We saved as a step file. We're going to call this and2 like we did in the previous case. Overwrite it, and I'm going to import this into SolidWorks. And this is the and2 file. Relatively small files, so this is on the order of less than a megabyte. SolidWorks has this automatic diagnostic. I'm going to initially say no because I want to break the link, which turns this just into an imported feature. And now I'm going to do the import diagnostics. Usually some of these faces have just a small issue with them, but you can generally heal all, which turns this into a fall-free geometry in this case here. So you can now see that this is a solid body, the solid side sections, and if we turn on the zebra stripes, you can see that these surfaces are completely flat and only sections of this and body stick out of it. If we look at the curvature, however, we see that there are some changes along here, and that's got to do with the fact that the definition here, make continuous, that's G1 continuous. If we wanted to see a smooth continuation across the surface, this would have to be a G2 type continuation, which the application currently doesn't support. So keep that in mind when you're looking at some of this stuff. It's G1 continuous. Now I want to show how this is different. So we're going to delete this. We're going to go back in here. We're going to turn continuous off. We're going to leave all the other options the same. We're going to do another preview. So we see these are now again nicely continuous patches. We're going to go ahead, export the same body. Yes, and this again you see initially was 0.6 and now it's down to 0.5. So it's a very small file. Go back in here and we're going to import this again. Gonna skip this, break the link, and we're gonna do import. Again, we're gonna have a number of facets that need to be healed. We get a good body out of that. And now if we turn on curvature, we'll see these patches are not continuous. Okay, so you see an actual edge to these patches, and that is because our continuous option has been turned off. That's what it essentially does. It looks at between these patches, can we create an overlap and then trim it during export. So that's what that does. And we can also change this to be non-uniform. So for example, if we have data that needs to be far more resolved in one than the other, we can, for example, change the number of Y samples down to 4. It has so cubic means a third degree, so we need at least 2 points internally, otherwise it'll switch to quadratic, which I recommend against. So make sure this stays cubic, which means we have to have at least 2. And then we'll click on preview, and we'll see it's a lot coarser along the Y axis sampling. So there's only 2 per block, and there's still the original 10 across the X. And the same goes for anything else. So we can, we can change those numbers, and it'll create different grid patterns for this. So it just depends on what you need for your application. If we like this as is and we want to create the mesh from it, we can click to mesh. And what it now does, it creates a new body that overlaps the other ones. So we'd have to go to the bodies tab, And if we want to delete the original one, we can either try and pick it directly, or we can click on this one, right click, and delete others, which will delete all the other items. And now we have something that represents the patch that we just generated here. Okay, I'm gonna leave this tutorial at this point. We're gonna have one more tutorial where we're gonna look at some of the export options and things to keep in mind for that.